Okay, let's dive into this. Welcome back to The Explainer. I am so incredibly thrilled to have you here today because we are going to master some of the most fundamental concepts in all of science: atoms and molecules. Now, I know chemistry can sometimes feel like this giant, intimidating wall of complex formulas and confusing words, but today we're going to break that wall down piece by piece. We're taking a completely conceptual approach, focusing on real, genuine understanding, not just blind memorization. By the time we finish, I promise you'll see the invisible world around you in a completely new light. Here's our game plan for today. First up, the smallest unit concept. Then, defining the atom. Third, what makes atoms different. Fourth, combining atoms into molecules. And finally, a quick revision summary. All right, let's get into it. Section 1, the smallest unit concept. Before we even think about throwing on a lab coat or, peering through a microscope, we need to take a step back. To really get chemistry, we gotta understand the everyday objects right in front of us. So what do a physical wall, the mathematical number 92, and the English word cat all have in common? I want you to really think about this for a second. At first glance, physical architecture, math, and language seem completely unrelated, right? But if you look closely at their structural pattern, they actually share a very specific foundational similarity. And this brilliantly illustrates our core concept today. Every complex thing you see is just a combination of basic, unbreakable units. Think about it. A wall is built by stacking hundreds or thousands of individual bricks. The brick is the absolute smallest, most basic unit of that wall. The number 92? It's just made of two single digits, 9 and 2. The digit is the smallest unit of any number. And the word cat, well, it's just formed from 3 letters, C, A, and T. A single letter is the smallest unit of any word. If you just keep this super familiar analogy in mind, everything we talk about next is going to be a total breeze. Moving right along. Section 2, defining the atom. Now, listen closely, because we are taking this exact same logic, the brick, the digit, the letter, and applying it directly to physical matter. Imagine you have a pile of salt, some sugar, and a glass of water on your desk. If you zoom way in and put that salt under a highly advanced electron microscope, you'll actually see it's made of 2 smaller things, sodium and chlorine. And here's a wild little fun fact. Sodium is a highly reactive metal that literally explodes in water, and chlorine is a toxic gas. But when you chemically combine them, boom, you get perfectly safe, delicious table salt. But here is the absolutely crucial part. You cannot, under any circumstances, split up that sodium or chlorine any further into simpler substances. They are the ultimate building blocks, the smallest possible units of that salt. Same goes for sugar. Zoom in, and it breaks down into carbon, hydrogen, and oxygen. Water, it breaks down into hydrogen and oxygen. Just like a brick is to a wall, these unbreakable units are the fundamental building blocks of all matter. Now, in science, we don't just call them building blocks. We have a very specific name for them. We define an atom as the smallest unit of any matter. Let me repeat that for you because it is literally the anchor of our entire lesson today. The smallest unit of any matter is called an atom. And I really want to explicitly bust a huge misconception right here, right now. An atom absolutely cannot be divided further into something else. It is the absolute smallest, simplest unit you can get. All right, Section 3. What makes atoms different? If you've ever glanced at a periodic table in a science class, you probably know there are 118 unique elements up there. That means the smallest unit of hydrogen is a hydrogen atom. The smallest unit of sodium is a sodium atom. And you guessed it, the smallest unit of carbon is a carbon atom. But wait a second. Let's do a quick conceptual check-in here. If atoms are the ultimate base units and they absolutely cannot be divided, why in the world are they all different from one another? Why doesn't a hydrogen atom act exactly like a carbon atom? What actually gives each atom its own unique personality? Okay, major exam alert here. If you have a notebook, definitely jot this down. Atoms are different from one another strictly due to their number of protons. Let me say that important statement one more time. Write it down. Atoms are different from one another strictly due to their number of protons. You can think of protons as a sort of magic identity badge. Change the number of protons and you entirely change the atom. Let's make this super concrete with some real-life examples. If you look closely at a hydrogen atom, you're going to find exactly 1 proton. That single solitary proton is exactly what makes hydrogen, well, hydrogen. But if you look at a carbon atom, the stuff that makes up diamonds, the graphite in your pencil, and literally all life on Earth, you will find exactly 6 protons. And the pattern just keeps going. A sodium atom has 11 protons. If you look at chlorine, you'll find 17 protons. This completely cements why each atom behaves so differently from the next. It is all about that core identity badge, the specific number of protons inside that smallest unit. And with that foundational rule totally locked in, we are ready to move on. Let's move to section 4, combining atoms into molecules. Now let's see how this builds into something even bigger. Remember our analogy from the very beginning? Combine bricks, you get a wall. Combine the digits 9 and 2, you get the number 92. Combine the letters C-A-N-T, you get the word cat. So what actually happens when we start combining atoms? We get a molecule. Here is your official definition. When two or more atoms combine together chemically, they form a molecule. I'm going to repeat that, and I want you to pay extra close attention to one specific word. When two or more atoms combine together chemically, they form a molecule. That word chemically is absolutely vital. A huge misconception out there is that if you just have a bunch of atoms floating near each other in a room, that's a molecule. Nope, not at all. They have to actually bond. They have to link up chemically to officially become a molecule. Let's walk through this step by step. Imagine you have one atom of oxygen. Now bring in another single atom of oxygen. If those two identical atoms combine together chemically, you get a molecule of oxygen gas, otherwise known as O2. Literally the stuff you are breathing in right this second. But here's the cool part. They don't have to be identical atoms. Watch what happens when completely different types of atoms combine. Take one atom of carbon and chemically combine it with two atoms of oxygen. Suddenly, you form something entirely new, a molecule of carbon dioxide gas, or CO2. Let's quickly highlight a couple of famous examples you will absolutely see on your exams. Hydrochloric acid, or HCl, is really just one atom of hydrogen chemically combined with one atom of chlorine. Ammonia gas, or NH3, is just one atom of nitrogen chemically combined with three atoms of hydrogen. So the absolute crucial point here is, no matter what complex substance you're looking at, it always comes down to combining basic units chemically. And finally, Section 5. Quick revision summary. You guys have totally got this. You now conceptually understand the foundations of literally all matter. So get your screenshot fingers ready, because here are your golden rules for perfect exam preparation. Rule number 1. An atom is the smallest unit of any matter, and it absolutely cannot be divided further into simpler substances. Rule number 2. Atoms are different from one another strictly due to their unique proton numbers. And rule number 3. When two or more atoms combine together chemically, they form a molecule. That is the core logic of everything we've covered today. So I want to leave you with this final kind of mind-blowing thought. Now that you know exactly how matter is built, from the unbreakable atoms to the complex molecules, take a look around you right now. What invisible atoms and molecules are you interacting with? The screen you're watching this on, the water you're drinking, the very air in your lungs, it's all just incredible microscopic architecture. Keep observing, keep asking those big questions, and never stop learning. Thank you so much for joining me on this explainer today, and I'll see you next time.